Hi lads, in this video I'm going to go through how to solve the solids are cut by an oblique plane. So the first one that I got you to do, it was the square-based prism. So you can see there I have a model made up of how it actually works. And if I just scroll back to what you would start off with initially. So you start off with your actual oblique plane there, and you have your vertical trace, your horizontal trace. After that then you would draw in your solid there. So you can see I've drawn it just before you actually cut it. So you can see there in elevation, that's it before it's cut, and in plan you'll have that square shape. After that then, just showing how we take one of our points over and up. So we go parallel to our trace there until it hits the XY line. We take our line straight up. After that, where that line hits the XY line, we take that straight up and across, and we continue our vertical line straight up to find out where the height of that cut is going to occur. So you can see before it's even cut, it's going to hit it roughly about there where the colour changes on the plane. After that then I've actually put in the cut showing the exact point of where it actually occurs. And then I've just drawn the rest of it in. So I just did one point instead of taking them all because it'd be very confusing seeing all the purple lines being taken up and across. I just showed about one. You can see where all the points occur then as a result. And that's your shaped outline. And you look in plan, the whole surface is cut as well. You can see in yellow where the cut occurs. So that was how to do that one there. The next one was the cylinder. I can get it just to open here. There we go there. So the cylinder, so the same idea again. If I just roll it back to what you would start off with. Too far back. Just there where you'd have your traces drawn in again. And then we have our cylinder drawn in fully there. And then when it's cut by the plane, it leaves that shape behind there. I've just once again shown an example there of one of my points. If I just look down, first of all on my plan, you can see there I picked a point on my cylinder, took it up parallel to the trace there, and then straight up. And where it hits the trace, or sorry, it hits the XY line, we take that straight up, across, and we continue that line straight up there, and it gives me a point. And you can see our elevation there. When you plot enough points, you're able to draw your freehand curve. And that's what it looks like in elevation and plan. And then the last one was the square-based prism. Sorry, square-based pyramid. If I just get it to load there. There we go. So I just scroll it back just to do the same idea again. So you start off with your oblique plane. If I just zoom right in there so you can see. You can see our trace is drawn in. After that then, I've drawn in the pyramid before it's actually cut. And the plan view there. And then the difference with this question is we can't actually take our edges out, over and up. We won't be able to actually project our points because they're all sloping inwards. So what we need to do is actually take an auxiliary view to solve this part of the question. So what I've done is I've created a plane here, and just like we will have done find the true inclination, if you look in to this side here there where you see the actual auxiliary view of the plane, by having that line there you see an edge view. You can see exactly where all the cuts occur. So at this edge here it cuts here. For this one, the front, and you can just tilt it up there, and the back, you can see it cuts at that point there, and you can see along this one it cuts here, so you get your heights there as a result, so you can actually take your points. It's very important for that one as well to take an auxiliary view, because if we look in at the plan, we wouldn't be able to actually take our points down here, because we're looking in at this angle here, looking in along this way. We won't be able to see where our height is hitting here and here, so that's why it's important to have an auxiliary view. We can see where our points hit this line here, sorry, this line here and here, but we can't see how far back it's going to hit, so that's why we have our height. So we'll be able to take it into our elevation and then finish off in our plan as well. So if I just go back to our auxiliary view, I should have a cut made here, but So yeah, you can see there, if we look in, I've already done the cut now there as well, showing where it hits it. If I look in perpendicular to our auxiliary view there we go. You can see there all the points going to cut along, and then I've actually projected that onto the surface there, so you can see that's your auxiliary view you would have with your x1, y1, your line showing your oblique plane, and then where the cuts occur there. And then what you can do then as a result is actually be able to take your points over and across, or sorry, down and then up into your elevation to get your heights here, 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 and here. And then for these two, as I was saying to you, how we can't see in the auxiliary when we take it back, sorry, on these two here. If we look at our elevation, we can have our height there, take it straight down, give us this point here. And then for this one here, when we take that height there straight down, it'll be able to give us that point there as a result. So hopefully that video helps anybody who would have been stuck on that.